A very good evening to all of those who are watching this video right now. And if I'm audible, you can just send a thumbs up in the chat box so that I can get a cue to start our most expected session. Yeah. Good evening. Good evening. So, am I audible? Okay. So, we will wait for 2 more minutes and let others join and then start. Okay. So, join fast, guys. Share this link. This is very important for your ICAR JRF, which is just knocking at the door. And we have brought our most expected series, keeping in mind the ICAR JRF pattern so that you can be benefited mostly from this session. Okay. Students from agronomy, soil science, or even to clear your general agricultural concepts also, you can join this session. So if I am audible, just give a thumbs up and we can start. Guys, if I'm audible, please drop your response in the chat box so that we can start. Okay, fine. So, hello everybody, I am Purbita Ma'am and I am currently pursuing my Masters in IARI New Delhi under the Division of Soil Science and Agricultural Chemistry. And I'll be handling the most expected series. So, in this session, this is the part 1. So, we'll have 60 questions and in the next session, we will have the rest 60 questions of the entire 120 marks. I'm fine. How are you guys doing? Are you studying enough? Okay. So, this is just my introduction slide and we will begin with our first question. Okay. So, the first one is an assertion reason kind of question. Read it thoroughly. Available nitrogen is measured as mineralizable nitrogen using the alkaline potassium permanganate. So, this was given by Subia and Asija. Okay, so this is your assertion. Now, you see that when we are determining the nitrogen, we have different forms. Okay, one is the total nitrogen determination we have. Then we have mineralizable nitrogen determination, mineralizable. And then we also have available nitrogen determination. So, here what it is talking about? It is talking about mineralizable nitrogen and this was given by Subia and Asija. So, this statement it is correct. Okay. Now, in this method, this nitrate nitrogen along with a portion of easily oxidizable organic nitrogen is estimated. So, can you drop the answer in the chat box? What will be the correct answer to this question? So, see, what does mineralizable nitrogen means? Mineralizable nitrogen means the portion of nitrogen that can be mineralized. Mineralized means that can be converted from organic forms to inorganic forms, right? Organic forms to inorganic forms. Okay, so option number A. Let's see if you are correct or not. Actually, it's option number C. Because not only the nitrate nitrogen, but also the ammoniacal nitrogen is present, right? So, that is also to be measured, not only the nitrate but also the ammoniacal nitrogen. So, that is why A is correct but R is not correct because here you also have to include the ammoniacal nitrogen, okay, along with that. So, I have written over here that it is often referred to as mineral nitrogen as both ammoniacal as well as nitrate forms are measured. Now, just related to this question is what are the different pools of nitrogen that are present in our soil. So the organic pool of nitrogen, can anybody tell that how much percentage of nitrogen is present in the organic pool? Okay. How much nitrogen is present in the organic pool? It is approximately 98%, right? 95 to 98% of the nitrogen is organic in nature. Rest is inorganic in nature. And within that inorganic pool also, we have two different groups. One is easily hydrolyzable nitrogen and the other is non-hydrolyzable nitrogen. So within the hydrolyzable nitrogen, we will have the parts of nitrogen that can be easily mineralized, like that of the nitrate nitrogen and the ammoniacal nitrogen, as well as the part of the humic acid that can be easily dissolved, that is acid soluble or alkali soluble humin, you can say. Then the non-hydrolyzable portion of the nitrogen will take into account the nitrogen that is fixed inside the different clay minerals. Okay, so the nitrogen that is fixed and it is not released. Okay, so clear this question, everybody? These pools of nitrogen are also given in your old ISSS book. So you must be thorough with what are the different kinds of pools present. Second question, enrichment of water bodies by nutrients and consequent bloom of algal and other aquatic plants. So drop the answer in the chat box, please, guys. Yes, yes, you all are correct. So it is eutrophication. So can anybody tell me that which of the following nutrients assumes most important role in eutrophication? Nitrogen or phosphorus? Which of the following? Which nutrient is more important for eutrophication process? Nitrogen and phosphorus, but phosphorus is dominant, okay? Phosphorus is dominant. It will mainly govern the eutrophication. So what is eluviation? Let's also explore the other options. What is eluviation? Yes, it is phosphorus. What is eluviation? Eluviation is when you have different kinds of horizon. When the clay moves from the E horizon to the B horizon, suppose it is getting deposited from the upper horizons to the lower. So this is called clay eluviation. And what is eluviation? So eluviation generally refers to washing in or washing out. Tell me, washing in or washing out? I am talking about eluviation. I-L-L-U. I-L-L-U. Yes, washing in is eluviation. You guys are writing out. It is not that. Eluviation is washing out because it is happening from the E horizon, right? From the upper horizon only it will wash out and then it will get deposited in the subsequent lower horizons. Okay. Now, so this I have written over here the description. Moving to the next question. The most common epipedon which are important in India. So which of the following epipedons are important? Yes, eluviation is washing in and eluviation is washing out. Good. So tell me quickly the answer to this. Yes, it is option number C. So we have remembered it like MOU. Okay, MOU. So these are actually the important epipedons. So what are the epipedons? They are present in surface horizon or subsurface horizon? Quick. Surface or subsurface horizon? Yes, all are giving the correct answer. Okay. So this epipedon, it is surface horizon or subsurface horizon? Yes, it is surface horizon. And if we talk about endopedons, then these endopedons, they will dominate the subsurface horizon, and that too at a depth of 15 to 38 centimeter approx. Okay. So this will be from 0 to 15 centimeter, but from 15 to 38 centimeter, endopedons will dominate. Now quickly tell me the characteristics of all these three different kinds of epipedons. So from the name itself, the name ochric suggests what? That it has very light color. Okay, it has very light color. In case of ochric, yes, it has very light color. Maulic suggests what? Maulic suggests that it has high base saturation is there, right? Yes, ochric is 1% organic matter fine. That means organic matter, if it is less, that means the color will obviously be light. And in case of maulic, what will happen? In case of maulic, your base saturation will be high. And in case of ambric, it will be similar to molic, but it will have a less base saturation. And what is folistic? This folistic epipedon, it will be saturated or not be saturated with water? Tell me, for more than 30 days, tell me. So, this folistic epipedon will not be saturated with water for more than 30 days. So, these are the major characteristics of all these different kinds of epipedons, and the one that is saturated with water for more than 30 days, it is istic. Got it? Clear the question? Yes, very good. Just a second. Okay. On this one. Okay. Now let's come to the next question. So here the answer is option number C. Okay. Now let's come to the next question. The main center for NBSS LUP is main center for NBSS LUP. So it is what? It is National Bureau of Soil Survey and Land Use Planning, right? National Bureau of Soil Survey and Land Use Planning. Yes, it is in Nagpur. N for N, we have to remember that. Now tell me, where is the All India Soil Survey present? All India Institute of Soil Survey. It is present where? Yes, okay. MG Patel is the director. Someone has said MG Patel is the director. Very good. I am writing it over here. So, this All India Institute of Soil Survey and Land Use Planning, it is located where? No, Bhopal. In Bhopal, yes, it is located in Dehradun. Now, see, in case of Bhopal, what is present? It is Indian Institute of Soil Science. Indian Institute of Soil Science is present in Bhopal. Now tell me the Space Application Center, SPSC, it is present where? Space Application Center is present in where? Ahmedabad, okay? So these are the some things that you have to remember, okay? Good. So this is located at Nagpur, fine. Now the A plus B horizon are collectively called as, tell me quick, very easy question, A plus B horizon are collectively called as? So for that you need to know the difference in between the solam and the regolith. Yes, option A only, very, no, it is not regolith. Who said regolith? No, it is not regolith. Actually you see that the solam is the true soil. Why is it called as your true soil? Because this is, suppose I am taking this as the entire soil body. So this is the uppermost horizon, that is O. Then we have A, then we have B, and then we have C, and we have R. So what happens, from this bedrock only, the weathering will start from the bedrock. Now as the weathering progresses, yes, A plus B plus C will be in regolith. As the weathering progresses, this material, that is the C horizon, will slowly give rise to B and A. So whatever is present in the topmost layer will be considered as your true soil, okay? And this part is called as the solam. And A plus B plus C is together called as your regolith. And what is regolith? Regolith is the unconsolidated parent material that emerges after the process of weathering. And solam is when the different soil forming factors as well as processes, they happen over the regolith, then it leads to the formation of the true soil or the solam. So you should not get confused between that. Now what is pedon? What is pedon? Pedon, it is the smallest volume of a soil. It is the smallest volume of a soil, okay? It is roughly hexagonal in shape, smallest volume, and it should be 3-dimensional. Smallest 3-dimensional volume of soil. Now, who can tell me, yes, smallest, who can tell me the maximum area of a pedon? Who can tell me the maximum area of a pedon? Yes, okay. Okay, fine. Yes. But in some books you will find that it is written kilometer square, so do not get confused. Okay. In some books you will also find that it is written as kilometer square, so do not get confused with that. When we talk about polypedon, it is a collection of pedons, and this polypedon will have a maximum area which is undetermined, but the minimum area of a polypedon is supposed to be 1 meter square. Okay. So you have to make all the concepts clear. Yes, area of polypedon is 1 meter square up to, yes, up to infinite. Okay. Now, sixth question, mycorrhizal roots can take up much more phosphorus than the non-mycorrhizal ones. Here there will be a non. Larger surface area resulting from the growth of the hyphae, and thus they increase the uptake of nutrients. Very easy question. Quickly write the answers in the chat box, please. Yes, it is option number A, because whenever mycorrhiza is what? Mycorrhiza is what, guys, tell me? It is a symbiotic association between fungi and the roots of higher plants. Fungi and roots of higher plants. And often you can get confused that maybe the mycorrhiza provides the nutrients, but it does not. Mycorrhiza does not provide the nutrients, whereas mycorrhiza helps in what? It helps in solubilization and mobilization of nutrients. Mobilization and solubilization. But it does not provide the nutrients like that of nitrogen fixing bacteria, such as rhizobium. Rhizobium or all the other nitrogen fixing bacteria, they can take up the nitrogen from the soil and they can provide the nitrogen, but they can only access the available source of nutrients that is present in the soil. Okay. Okay, fine. So the correct answer will be option number A. Very good. Now, two non-metallic elements occurring in greatest abundance in the earth's crust. So this is also a very prominent question. So, OC alpha Mg, right? This is the sequence. Yes, oxygen and silicon. So tell me the percentages also. Then I can know how better is your preparation. So it is around 46%, right? This is around 27%. This is around 8.1%. 5.83%. Calcium is 3.63, I believe. Yes. Sodium is 2.8. Then this is 2.5 and this is 2.06. So these are the overall percentages of nutrients that you have to keep in mind. Yes, 46.6 and 27.72. So if you sum it up, then you will find that it is coming greater than 70%. So if somebody asks that what is the most abundant element that is present in the earth's crust, then for the element what will come? Oxygen. It is the abundant element. If somebody asks that what is the most abundant exchangeable cation, then it will be calcium. Most abundant exchangeable basic cation. Okay, it is calcium. So these things you have to keep in mind. So see, both contributes around greater than 70% to the earth's crust. Centigrade and Fahrenheit scale gives the same reading. And so this is a class 9th sum. Okay. If anybody cannot do it, then I will send them to class 9. Quickly do it and this tell me the answer. Yes, it is option number B. So which formula did you apply? It is C by 5 is equal to F minus 32 by 9. And for C and F, you can consider that it is suppose T degree centigrade, and then when you equate this, you will get minus 40 degree centigrade. So this is the answer. Clear? Okay. Now, coming to the match the following question. This is also a very, very easy question. Very easy question. Tell me quickly. So, bulk density. Bulk density, we measure it in gram per centimeter cube or megagram per meter cube. Okay. So, this will be option number 1, right? Okay. Option number 8 is coming. So, it is option number 1. Very good. CEC, we measure it as centimole P plus per kg. Who can tell me what is the another unit of CEC? What is another unit of CEC? Yes, option A will be the correct answer, but who can tell me what is the another unit of CEC? So we can also write CEC as meal equivalent per 100 gram of the soil. Meal equivalent per 100 gram of the soil. Not meal equivalent, but it should be meal equivalent per 100 gram. That you have to mention how much soil you are taking. Then who can tell me what is the relationship between 1 megagram per meter cube and 1 gram per centimeter cube? What is the relationship in between these two? 1 megagram per centimeter cube is equal to 1 megagram per meter cube is equal to 1 gram per cc. Okay. This formula you have to remember. This is same. Okay, equal. Then for the CEC we have decisiemens per meter. So decisiemens per meter equates to another unit which is micromohos per centimeter. You should be clear with all the units. These two are equal. And then, sorry, this is the electrical conductivity. And the pH, it is obviously, it is unitless. Okay. Let's move to the next question. Azonal soils are. So, this classification of zonality of our soils was given by our great father of soil science, who is Dakuchev. And he gave three classifications. One is zonal, one is intrazonal, and the other is azonal, right? So, in case of zonal soils, they will be dominated by, okay, options are already coming. So, it is option number B, that is alluvial soil. Now, why? In case of zonal soils, they will be dominated by the effect of climate, okay, as well as the other active soil forming factors. In case of intrazonal soil, they will just depend on which region they have formed, for example, hydromorphic or halomorphic soil. And in case of azonal soil, they have just started formation. So, alluvial soil, you all know that it either belongs to antisol or inceptisol group, which are either embryonic or baby soils, right? So, they will fall under the azonal group, whereas this red soil, vertisols, black soils, all of them, these red soils, though they are highly weathered in tropical conditions, so they will fall under the zonal soil. Now, so this is our batch, and you can access it at a great discount. And if you like our sessions in YouTube, then you can always subscribe, and you will find this most expected bundle in our batch as well, in the form of mock test. Okay, so please do subscribe. Now, which is not a property of biofertilizer? So yes, regosol, then lithosol, then alluvial, yeah. Now, which is not a property of biofertilizer? So, biofertilizer means what? Biologically active products containing live microorganisms. So, this should be true. Environmental friendly also. This is also cost effective. And this is okay. Now, one thing is that these biofertilizers, these are not rich in nutrients. These are not rich in nutrients. I already mentioned that whenever you apply biofertilizers in your soil, other than nitrogen, no other organism has the capacity of fixing or bringing in the unavailable nutrient form. So, they will access only the nutrients that are present in the soil. So, option D will be our correct answer. Okay. Parent materials deposited near the base of the strong slope by the action of gravity. So, quickly, this is very easy. Okay. This is based on the different agents of weathering. So, lacustrine means lakes. Okay. And in case of lakes, the coarser fragments will be deposited near the shore and the finer fragments will be deposited near the middle. So, this is for the lacustrine. Now, for the colluvium, yes, options are already coming. So, colluvium is by the action of gravity, and then we have alluvium. So, alluvium, it is by rivers. Aeolian, it is by wind, but sand or silt? Comment please, sand or silt, which one? For Aeolian? Yes. No, 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 not silt. No, not silt. It should be sand. Okay, for the silt it is lowest. For the silt it is lowest, not Aeolian. Okay. Please do not get confused. Okay, it is for sand, it is not for silt. And if it is normally flown, normally dropped by flowing water, then it is outwash. Flowing water is outwash. Glacial deposits are till and moraine. So, you should be very, very thorough. Okay, with the weathering agents. Now, Improved soil and nutrient management practices help maintain the productivity and soil water qualities. Obviously, this is true. They reduce nutrient losses and enhance soil health. So, this is also a very easy question. Tell me what should be the answer? What should be the answer? Yeah, obviously, it should be option number A. Now, natural soil aggregates are known as natural soil aggregates. Okay, tell me. I had already mentioned pedons, right? I told that pedon is a natural soil body, three-dimensional. So, from pedons only beds will come. So, these are natural. Now, what is clod? Clod is artificial, that you make or break while tilling the soil. And floccules are nothing but these are the aggregations of different soil structures. Either it can be calcium, organic matter, clay, like that. Then concretion or nodules, it is of CaCO3 calcareous deposits that are present in the soil. Okay, yes. So, PETs will be your ultimate answer. And who can tell me? Aggregation is equal to flocculation plus what? Aggregation is equal to flocculation plus what? Tell me, quick. Aggregation is equal to flocculation plus, yes, cementation. Very good. Okay. Amount of water vapor in the air could hold with comparison to its saturation point. Very easy question. That means what is the percentage of water vapor that is present in your atmosphere divided by the percentage of water vapor that is supposed to be present at a saturated condition. But mind you, the temperature in both the cases must be same. So, this is the example of relative humidity. Now, what is absolute humidity? It is whatever volume of water vapor or percentage of water vapor 1 unit volume of air. 1 unit volume of air is holding. Okay. Variable humidity will vary, fixed humidity is fixed. So, these are not scientific terms, but another thing is specific humidity. So, in case of specific humidity, we measure it per kg of air. Okay, so we consider the mass of air in case of specific, and we consider we consider the mass of air in case of specific humidity, and for absolute humidity we consider the volume of the air. So, it is meter cube, not kg per meter cube. Okay, not kg per meter cube. It is meter cube per meter cube, you can say, or you can say that if the volume is present in meter cube per kg, but not kg per meter cube. It is the unit of density. Okay, Aman. Now, a tensiometer will measure the metric potential of soil water. So, we have questions from soil water. Fine. Tensiometer will measure the metric potential of the soil water. A very true statement, because now answer guys quickly. Because the tensiometer cannot measure the osmotic potential. We know that two potentials are dominant. One is osmotic potential and the other is metric potential in our soil. Tensiometer cannot measure the osmotic potential because whatever porous cup you are placing inside the tensiometer, it has large enough holes so that the soil salt concentration is in equilibrium with that of the tensiometer. So, it cannot differentiate between the concentration of the soil as well as of that of its porous cup. So, it cannot measure the osmotic potential. Okay, answers are already coming. So, it can measure the metric potential only up to minus 0.85 bars. Okay, only up to minus 0.85 bars. And in a tensiometer, suction by the soil causes water to move out of the porous cup, creating a vacuum that is registered by the manometer. So, this manometer is actually a primitive kind of tensiometer. In the modern days, we use what? We use vacuum gauge. We use vacuum gauge for the tensiometer. So, option A will be your correct answer. Okay. Now, so another thing regarding tensiometer that you should remember is that it is generally measured, or it is generally useful in sandy soils, number 1, and in the near dry zone, near dry range. So, it cannot measure water in case of saturated soil condition, and the soil should be sandy. Okay. Now, most of the gaseous interchange in the soil occurs by very easy question. It will be okay. Best use for scheduling. Yes, tensiometer is also used for scheduling irrigation. Fine. Tell me this one. Okay, option number A. So diffusion, in case of diffusion, we generally measure the partial pressure gradient. Okay, partial pressure gradient, and in case of mass flow, we measure the total pressure gradient. And if I had written over here nutrient exchange instead of gaseous exchange, which one would have been the correct answer? If I wrote here nutrient exchange instead of gaseous exchange, then which one would have been the correct answer? Quick. So if I replace this gaseous word, yes, it should be mass flow, because in case of mass flow, what will happen? The nutrients will flow along with water. But in case of diffusion, the nutrients will flow through the water. So water will act as a medium, and only nutrients like phosphorus mostly, or some amount of zinc, okay, they, or some amount of K, so they will move by this process of diffusion, but all the other nutrients will move by the process of mass flow. Okay. Next. Example of 2:2 type silicate clay mineral. Very easy question. So 2:2 type 2 means 2 tetrahedral sheets will be present. 2 tetrahedral sheets. We can also write it as 2:1:1. So 2 tetrahedral sheets will be present. Yes, 2 tetrahedral sheets, and 1 is your octahedral sheet. So what is the other sheet? What is the other sheet? Tell me. So in chloride, yes, I say that chloride is the correct answer, but what should be the other sheet? Which sheet is present in chloride? Yeah, it is Mg, magnesium brucite layer. So magnesium brucite layer, it is present, like magnesium is there and 6 molecules of water or 6 molecules of hydroxyl is present. Only one difference is there between the brucite sheet as well as your octahedral sheet, is that this is not connected to any of the other sheets. But if it were the octahedral sheet, then it would have been connected to the other sheets. Yes, brucite layer. But this brucite layer is generally dominant in alkaline conditions, when the chloride is in alkaline form. In case of acidic conditions, aluminium gypsite layer is dominant. What? Aluminium gypsite layer is dominant. So these things you have to keep in mind. Kaolinite is 1:1, montmorillonite is 2:1, vermiculite also 2:1. So which of the following clay minerals has the highest cation exchange capacity? Which has the highest cation exchange capacity? Quick. So I have two questions. One is highest CEC highest and highest surface area. Quick. Yes, vermiculite should have the highest cation exchange capacity and montmorillonite should have the highest surface area. So do not get confused. CEC of vermiculite. Comment. What should be the CEC of vermiculite? It should be 80 to 150. Okay. C mole P plus per kg. Yes, vermiculite should be the correct answer. So it is 80 to 150, whereas for montmorillonite it is only 80 to 100. 10 to 150, who is writing? 80 to 150. Okay. Next. Soil acts as a physical, chemical and biological filter for various substances, and its capacity to perform these functions is infinite. Tell me. So the first option is obviously correct. First option is obviously correct, but what about this one? Is it really infinite? And that's why we are so concerned with the erosion and conservation part now. So this is not correct. Okay, so A is correct, but R is not correct, because its capacity to perform these functions is not infinite. Now, who is writing A? Aman, at least read the question. Okay, at least read the question. Okay. Now, the soil having more than 30% organic matter. This is also very easy question from the soil orders. And just to mention, we have 12 soil orders that we write with Avagami house. Okay, we have 12 soil orders and that we mentioned by the Savagami house. Vertisol, histosol. Who is writing? Hey, Raman Gandhi. It is not vertisol. Okay. Do not get confused by this 30% organic matter. Obviously, see, histose means tissue. Histose is tissue, right? So wherever the tissue content will be more, the organic matter content will obviously be more. Okay. Then for the oxysol, it is highly weathered soil. So in case of oxysol, this can't be. In case of alphisol also, it is highly weathered soil, acidic kind of soil found in tropical areas. And for the vertisols, these are the cracking clay soils or the black soils. Okay, cracking clay soils or the black soils. Ma'am, would we also have learned the chemical formula of phyllosilicates? Actually, you can at least remember the formula for each and every sheet. Like for the tetrahedral sheet and octahedral sheet, you can remember that, and then based on that, you can easily find out the formula. But no need to memorize the formula. You can find it out from the octahedral sheet as well as the tetrahedral sheet only. How? Now, in case of octahedral sheet, what will happen? Either there will be magnesium or aluminium. So, if it is dioctahedral, then there will be aluminium. Sorry. If it is dioctahedral, then there will be aluminium present. So, 2 aluminium will be present, and if it is trioctahedral, then magnesium will be present, surrounded by 6 water molecules. How many marks are required to get college for open and OBC category? Actually, it depends on to get college. You can get a college, at least you can get a good college if you score 300 plus. 310, 20 to good college. For OBC category, I am saying. For general, at least you have to get 330, okay, 320 plus to get a good college. College, though, you can get depending on the cutoff and all that. It again depends on the cutoff. But you should score at least, you should have a target of at least 350 plus in JRF. For everybody, I am saying at least 350 plus you have to have. How many numbers are required for IARI? 380 plus should be your target. Even at 380 plus, some people don't get, but 380 plus should be your target. Again, it depends on the cutoff. Again, it depends on the cutoff. So if your suppose cutoff is 400 plus, then 380 plus. If you are from general category, there is a 50-50 chance. Maybe you can get, maybe you don't, but at least try to focus at 380 plus. A few, huh? Okay. To get under 10 rank, how much marks is required? Okay. So to get under, it again depends on the cutoff, but 350 plus you can. For this year, the cutoff was around 390 something, 396. So the students with 350 plus 350, they also got under the 10 rank. So everything depends on the cutoff. How many? I cannot understand your question. Okay, so just let's move. Okay, state quota rule also, yeah, it is there. Okay, now, okay, let's move to the question. So histosol is greater than 30%. Now, which is not a chemical weathering? Which is not a chemical weathering? Oxidation means what? Oxidation means loss of electrons, right? Loss of electrons. Oxidation means loss of electrons. Then carbonation means addition of carbon dioxide or bicarbonate ion, breakdown with either carbon dioxide or bicarbonate ion. Hydration means what? Hydration means this addition of water. And hydrolysis means double decomposition. So all are the processes of chemical weathering actually. But I will add 2 more options for you. B, hydration. Hydration. How is hydration? Hydration is also a process of chemical weathering, but okay. I will add 2 more options for you. Okay. So I can here add exfoliation. Suppose it is option number E. And then I can also add pedoturbation. Then I can add reduction. So tell me. So these 3 options, see and tell me. Exfoliation, pedoturbation, reduction. So which of the following is a chemical? One. Okay. Which of the following is a chemical one, I am asking. Chemical process. Yeah, not a chemical process, exfoliation and pedoturbation, but chemical process, it is reduction. Okay. Yes, A and F, E and F are not chemical. Okay. So from here, tell me that which is the most important process required for the formation of clay minerals, primary minerals, suppose. Most important process for primary minerals. Most important process for primary minerals? Yeah, it is hydrolysis. But whenever I say for secondary minerals, important topics from agrochemicals, it will all be covered in due time. Okay, don't worry. Yeah, it is hydration. So for secondary it is hydration, for the primary it is hydrolysis. Hydrolysis is also called as double decomposition or the forerunner of clay formation. Okay, okay. Now, so this is not right. Okay, now see, as per WHO, the safe limit of nitrate content in groundwater. Safe limit of nitrate content in groundwater. So this nitrate is NO3N. So direct line is mentioned in your treatise book. So this has been directly taken from the treatise book. Yes, it is option. It is 10. So it can be milligram per liter. It is measured in milligram per liter. You can say, or even ppm. Okay, milligram per liter or ppm unit, both are same. And this nitrate nitrogen, excess of nitrate nitrogen causes which disease? Tell me. Causes which disease? Excess of nitrate nitrogen causes which disease? So I will be writing it in blue, suppose. Yeah, it's methanoglobamia or blue baby syndrome. Methanoglobamia or blue baby syndrome. So always remember, it is due to nitrate nitrogen, not ammoniacal, not nitric oxide, nothing, only nitrate nitrogen. Yes, okay, fine. You guys are doing great. Size of silt fraction according to USDA classification. Tell me. USDA system. So in USDA system, first tell me that what are the different classes. So we have 7 classes, right? 7 classes for USDA, and within that 7 classes we have clay, we have silt, then we have very fine, fine, medium, coarse, very coarse. Okay, right? Okay, so everybody is saying option number A. So for the clay, in each and every class it should be less than 0.002 millimeter. So also comment whether these are the diameter or these are the radius. Diameter or radius, what is given? Diameter or radius? Okay, another thing, for the ISSS classification, we have 4 classes. Okay, and in these 4 classes, we have clay, we have silt, we have coarse sand and fine sand. Coarse and fine. Sorry, here I should have written. Yes, this is fine and this is coarse. So, tell me. Yeah, these all are diameters. So, often the question might come that mention the radius. So, it should be divided by 2. Whatever you are doing, it should be divided by 2, and that will give you the answer for the radius. Okay. But here it is diameter only. So, in ISSS also there are 4 classes. Now, tell me that what is the ratio. When I was teaching in the class, I had already mentioned that what is the ratio of increase in the particle size for ISSS. It is 10:1. So each particle will increase by 10 times. Yes, very good, Aman. And for the USDA classification system, each particle will increase twice. Okay, nearly twice that of the previous one. So this way you can remember that what are actually the class portions or fractions. Only remember the clay and only remember the upper limit of the sand, which is 2 millimeters for each and every system of classification. Lower and upper limit you memorize and then you can easily do. 2.5 or 2, yes. Fine, no worries. Okay. Now, match the following. So, this has been taken from soil fertility. Oh, sorry, this is mineral. Okay, zinc. Tell me, zinc. Okay. Someone is saying C. What about the others? So, see this first. I'll say pyrolusite. So, also comment the formulas for the minerals. Okay. Comment the formulas for the minerals. Okay, Khush is saying B. So, Khush is only the odd one out. So, let's see who wins. Okay, so for the pyrolusite, it is MnO2, right? For the hematite, it is Fe2O3 dot XH2O, suppose I am writing. For the sphalerite, it is ZnS, and for the chalcocite, it is CuCO3. Okay. So, yeah. So for the zinc, it is pyrite. So A is option number 2. B is option number. This is option. So this is the correct answer. Okay. So whenever you are doing match the following questions, I'll give you one tip that always go by elimination method. So whenever you see that, see only here A is 2 in one option. So you do not have to check other options as well. This way you can save time. Chalcocite is wrong. Yeah, okay, okay. So what will be the formula for the chalcocite? Tell me. That is chalcopyrite. That is chalcopyrite as far as I remember, the Cu2S. Go and check it once and tell me again, okay? I think that Cu2S is chalcopyrite. Okay. Okay, no, it is chalcocite. Okay, sorry. It is chalcocite. Okay, fine. This is not CuCO3. So this is ZnS and this is Cu2S. Okay. Thank you. Thank you. Priya Dev. Okay. Thank you. Now, moving to, so here again, you can join our batches for the live classes so that you can get preparation. You can do your preparation well for the ICAR JRF because it is already knocking at the door and we have special prizes. See, we have also launched some special mock test bundles and all that. So, these all questions you will get here in our course. Okay, so please do subscribe. Now, the rate at which atmospheric temperature decreases with increase in altitude. So, what will be the answer? Okay, this is very easy. The rate at which atmospheric temperature decreases with increase in altitude is, yes, option number D, lapse rate. So there are different kinds of lapse rate. One is environmental lapse rate. So that environmental lapse rate is 6.4 degrees centigrade per kilometer ascent. Okay, 6.4 degrees centigrade per kilometer. Next, we can also have wet adiabatic and dry adiabatic lapse rate. So for the wet adiabatic lapse rate, it is also like less than ELR, which is 6 degrees centigrade per kilometer ascent. And for the dry adiabatic, it is 9.8 degrees centigrade per kilometer. So in this condition of your atmosphere, yeah, it is 10 or you can say 9.8. So in this condition of your atmosphere, what we see is that wet adiabatic lapse rate, it is the least, then the environmental lapse rate and the dry adiabatic lapse rate. So this is conditionally unstable form of atmosphere. Whenever there will be inversion in temperature, then your wet adiabatic lapse rate, it will increase. So in that case, we can say that the atmosphere is properly stable, but this is conditionally unstable form, okay, that prevails in our atmosphere. Now, temperature rate atmosphere, okay. Now, 26. Question number 26. Water flow in soil plant atmospheric continuum, which is SPSC, occurs along the gradient of increasing water potential. So, we know that water will always move from minus or plus. Which one? It is minus because all are lapse rate, no? It is minus. Lapse rate means what? The temperature is decreasing, so it is supposed to be minus. Okay, in case of inversion only, it will be plus. Now, we all know that water will move from high potential to low potential, okay? Water will move from high potential to low potential, okay? Yeah, okay. The lowest water potential exists in the atmospheric boundary layer around the lip. Yeah, so water will move from, so it cannot be option number B. Who is writing option number B? Okay, let's see. So, water will always move in the gradient of decreasing water potential, right? It cannot be increasing. It will move from high potential to low, so it is decreasing water potential. Yes, A is not correct, but R is correct. And the lowest water potential will exist in the atmospheric boundary layer around the leaf. So, this question also comes that which of the following, soil, plant or the atmosphere has the lowest? So, always remember that the leaf water potential is the lowest, okay? And that's why the water will enter into the plant. It facilitates the entry of water into the plant. So, it is option number D, okay? Yes, fine. Elements strongly bond to organic matter. Elements strongly bond to organic matter. So, we can solve this question with the help of one series that we call as Irving, William series. So we can solve this question with the help of Irving-Williams series. And this Irving-Williams series will actually, yes, all are writing the correct answer, that is copper. So Irving-Williams series actually depicts the relationship in between the micronutrients and that of organic matter, that how strongly, no, the answer will not be iron, the answer will be copper. How strongly copper is bond, or how strongly the micronutrients are bond with the organic matter, that is depicted. For the iron, okay, for the iron the bonding is less than that of copper. Less than that of copper. Okay, so iron will not be the answer. Copper is there. Okay. Okay. Let's move. The process of nitrification causes soil acidity. Okay. Nitrification means what? The process of nitrification means what? So when ammonia is getting converted to nitrate and then to nitrite. This is the entire process of nitrification. And in this entire process of nitrification, it is actually releasing the H plus ions, right? So it will cause soil acidity. This is correct. Then the nitrification will absorb the ionic hydrogen ions into the soil. Okay, it will absorb the ionic hydrogen ions into the soil. So what you guys have to say about this? Let's see. Option number A. Okay, Raman is writing option number A. So you see that whenever nitrification is happening, because the ionic hydrogen ions are present in the soil, it is causing the soil acidity. That is correct. So you see that nitrification will be, it releases hydrogen. Okay, during why is it written D? It increases soil acidity and lowers the pH. So why is it written D? Okay, so this should not be D, this should be A. Okay, because you guys are correct. That is, both the statements 1 and 2 are correct in case of nitrification, because it is true that whenever nitrification is happening, the hydrogen ions, they will be present in the soil and they can either contribute to the active acidity of the soil, or they can exchange the different kinds of basic cations that are present on the exchangeable complex, not aluminium, sorry, they can exchange the different kinds of basic cations that are present on the exchange complex and can also contribute to a part of the exchange acidity. Not absorb it, release it. Nitrification absorbs H. Okay, yes. So it will be release. Yeah, you guys are correct. Yes, this should be release. So it should not be yes. Yes, you guys are correct. So this should be release. So statement 1 is correct, but statement 2 is incorrect. Statement 1 is correct, but statement 2 is incorrect. So option number C should be our correct answer, right guys? Ma'am, pH increase होता है, nitrogen fixation increase. pH, okay, pH increase, nitrogen fixation increase. Okay, why with the increase in pH, the nitrogen fixation increases? See, nitrogen fixation can only increase. So just wait, let me clarify this first. So this should be option number C, not D. Okay, the nitrification or nitrogen fixation will increase in this pH range, 6.5 to 8. But it cannot increase beyond the pH of 8. Why? Because in case of nitrification, we have two kinds of bacteria. One is Nitrosomonas and the other is Nitrobacter. Nitrosomonas, always remember, they are the resistant bacteria. They will resist the changes in pH, they will resist the changes in temperature. So they can also prevail at higher pH level. But whenever the pH will exceed beyond 8 and it will go up to 9, this Nitrobacter will stop functioning. So Nitrobacter stops functioning means what? You have an excess of NO2 in your soil now. And that excess of NO2 is not getting converted into NO3 because the Nitrobacter becomes inactive in that case. Okay. So that is why up to this pH range only, this nitrification or nitrogen fixation, it will dominate. But beyond the pH of 9, the Nitrobacter will stop functioning and there will be nitrate toxicity in your soil. Okay. So it is not that with the increase in pH it will increase, but it will move up to a certain pH. This is the optimum pH, and after after that it will decrease. Okay. Okay. Now, clear? Did you get your doubts cleared, Shomik? Okay. Now, ammonium fixation is more in. Okay, so this question has been directly taken from new ISSS. Yes, vermiculite. Now, why? Why is vermiculite the answer? Let's see. So, in case of ammonium fixation, we have studied that in case of this K plus or NH4 plus, these two ions, they will fit very well in the ditrigonal cavity. They form the ditrigonal cavity and their radius matches that of the ditrigonal cavity of the vermiculite as well as the montmorillonitic minerals. So, whenever this K plus or NH4 plus will be present, they have very low hydration energy. Hydration energy is less than that of the interlayer force. That is the force with which the two layers are bound together. So, whenever moisture is there, so in case of vermiculite, yes, okay, when in case of vermiculite, whenever moisture is there, this NH4 plus will be so much embedded in the vermiculite that even if moisture is there, the water will not come. So, what will happen? Suppose this is the vermiculite and this is suppose this NH4 plus ion is there inside the layers. So, in case of moist condition, if the water comes from outside, it can form a hydration shell over this NH4 and that can break the mineral. But generally in case of vermiculite, that does not happen because the interlayer attractive forces are so strong that it cannot release the ammonia. So, vermiculite will fix ammonia both in moist as well as in dry conditions. Both in moist as well as in dry conditions. But for montmorillonite, it can only fix the ammonia in dry conditions but not moist conditions, because whenever moisture will be there, this ammonia will break down from the structure of the montmorillonite and it will lead to the breakdown of the mineral. Got it? Got it, everybody? Are you getting it? So, this has been taken from new ISSS. Okay? Yes, vermiculite. Now, coming to the next question. Yes, so swelling will not happen. Higher categories are defined genetically, not by soil. So, this is asking that which is not a limitation of genetic system. So, this genetic system of classification was given by, I just mentioned, our father of soil science, who is Dokuchev. Now, can anybody comment who is called as the American father of soil science? American father of soil science? So, I am writing the question here, American father of soil science. Who is the American father of soil? Yes, it is Marbut. And Dokuchev gave his genetic system of classification, but Marbut said no, I want to focus more on the morphological properties. Okay. So, he gave the morphogenetic system of classification. So, that is different. Then higher categories are defined genetically, that is on the basis of formation. Okay, light. On the basis of formation but not by the soil properties. So, this is asking that what are the limitations. Order concepts has clear property based definitions. Great soil groups will rely on environmental factors, making them comparative and qualitative. Okay. Great soil groups. So, first let us write that it is order, then suborder, grade group, subgroup, family and series. So, this is the entire hierarchy of soil classification. Okay, so Aman has only commented. So, what about the other guys? Many soils are classified by properties visible only in virgin conditions, lost after the cultivation. Okay, it is saying not a limitation. These are all limitations and order concepts have clear property based definitions. Okay, so let's see whether Aman is right or not. Yes, it is option number B. Why? Now see, whenever we are classifying a soil, we have like in genetic system, they had only taken the virgin soils, but not the cultivated one. So, whenever cultivation happens in a soil, it will change the soil properties. So, that is not in accordance with the genetic system. Higher categories are not defined, are defined genetically, not by the soil properties. Okay, this is a limitation, obviously, that it is defined genetically but not by the properties. Order concepts has clear property based definition. So, this is only the exception, because yes, it has clear property base, but it is not based on the genesis. Grade groups will rely on the environmental factors, and you cannot rely on the environmental factors for a universal soil classification system. So it should be option number B. Okay. Essential element for the synthesis of auxin. Very, very easy question. Comment, guys. Yeah, it is zinc. So indole acetic acid is there. Huh? Indole acetic acid or auxin, it is formed by zinc. Okay. Okay. Now coming to the next question. Area of micro watershed. So this is again a question from general agriculture. Tell me. Zinc. Okay. So give me the area. Sub, milli, micro, mini, macro. Okay. So this is the order: sub, milli, micro, mini, macro. And for the macro, greater than around 50,000, I believe 50,000 hectares. Then this is 50 to 10k. Huh? This is 10k, 10,000 to 1,000, 1,200 like that. Okay, let's see. So macro, it is yes more than 5,000. Yes, option number C is the correct answer, not option number B. Okay. Sub macro is this, or you can say sub, yes, milli, then micro, then mini. So let's see if I had written right. Yes. So sub, milli, micro, mini. So this is the overall classification system. So it should be option number C. Okay. Okay. FAO headquarters is located in. So FAO is Food and Agricultural Organization. So its headquarters is located in. Okay, let me show you the answer only. So it is located in Rome, Italy. It is located in Rome, Italy. So can anybody tell me in Geneva what is situated? It is World Meteorological Organization, WMO. It is situated in Geneva. And another important organization is situated in Italy, which is the International Institute of Plant Genetic Resources, I believe. So right now I cannot remember the appropriate name, but it is somewhat related to plant. Just check it, okay? In Nimrat Sunda it is given properly. Now, this is analytical chemistry, Barclay and Black method. Quick, Barclay and Black method. Okay. Yeah, okay, fine. So, Barclay and Black method? Yes, it is option number D. Okay, everybody is writing option number D. So, you have to also tell me the reagents, okay? Not like this, the reagents as well. So, in case of Barclay and Black method, we use chromic acid, right? H2SO4 plus K2Cr2O7 dichromate will form chromic acid, and that chromic acid will oxidize our organic carbon into carbon dioxide. Color change quickly. What should be the color change in Barclay and Black method? So it should be orange to, this should be the color change, right? Alkaline KMNO4 for available nitrogen, yes. So I am talking about Barclay and Black. So let's concentrate first on Barclay and Black and then we will go over there. So orange to green color, it will be there from +6 to +3 stage. And then we have to titrate whatever carbon has not reacted with the reagent. We have to